Here are the solutions to the VCAA 2017 Further Mathematics Written Examination 1. We are going to start with Section A, Core Data Analysis. Use the following information to answer questions 1 to 3. The box plot below shows the distribution of the forearm circumference in centimeters of 252 people. Question 1 is asking for the percentage of these 252 people with a forearm circumference of less than 30 centimeters. From the box plot, 30 centimeters actually represents the third quartile Q3. As you already know, the percentage of data under the third quartile is 75. So the answer we are after is option D, 75%. From the 2017 VCAA examination report, we learned that 93% of students had the correct option. So this question was answered extremely well. In question 2, we are asked to determine the 5-number summary for the forearm circumference of these 252 people. The 5-number summary consists of the minimum value, Q1, the median, Q3, and the maximum value. Looking at the 5 options, we notice that Q1, the median, and Q3 are exactly the same. So what is going to distinguish between the 5 options? Well, that is going to be the minimum and the maximum values. From the box plot, the minimum value is 21 centimeters. So the options we are going to look at are options A and B. We can now cross out options C, D, and E. The maximum value is very close to 36, so we can say it is 35.9. For this reason, we can cross out option A, so the answer we are after is option B. From the 2017 VCAA examination report, 58% of students had the correct option. However, 38% of students had an incorrect option C. Let's see why this happened. Option C has a minimum of 24.5 and the maximum of 34. What these students did, they ignored the outliers. Just remember that the outliers are still part of the set of data, so they have to be considered when determining the 5-number summary. Question 3 is still related to the data in questions 1 and 2. However, this time we are given a table of values that shows the forearm circumference in centimeters of a sample of 10 people selected from this group of 252 people. The question is asking to calculate the mean, x bar, and the standard deviation, Sx, of the forearm circumference for this sample of people. Using available CAS technology, we are going to use TI Inspire here, which is add, list, and spreadsheet, and then enter the data in column A labeled circumference. Next, from the menu, we are going to choose statistics, stat calculations, and one variable statistics. One variable because we only have one variable, which is the forearm circumference. Then we click OK twice and we read the results from the screen. So the mean x bar equals 27.8, correct to 1 decimal place, and the standard deviation Sx equals 1.66, correct to 2 decimal places. So the answer we are after is option D. From the 2017 VCAA examination report, 88% of students had the correct option. So this question was answered quite well. In question 4, we are given a histogram that shows the distribution of the log in base 10 of area, with area in square kilometers, of 17 islands. The question is asking for the median area of these islands in square kilometers. First of all, we know that the position of the median is given by the formula n plus 1 all divided by 2, where n is the number of scores. In this case, n equals 17. So 17 plus 1 equals 18, divided by 2 equals 9. So we are going to look for the 9th score. From the histogram, we can see that the frequency of the first column is 1. The frequency of the second column is 3. And the frequency of the third column is 4. When we add up these frequencies, they add up to 8. So the 9th score is going to be between 3 and 4. Now remember that this is log in base 10 of the area. So log in base 10 of the area is between 3 and 4. So we have to convert this logarithmic inequality to an exponential inequality. And this gives us the area between 10 to the power of 3 and 10 to the power of 4. In other words, the median area is between 1,000 and 10,000 square kilometers. So the answer we are after is option D. From the 2017 VCAA examination report, 62% of students had the correct option. However, 22% of students had an incorrect option B. Why did this happen? Well, these students chose option B because of 3 and 4. They didn't convert log in base 10 of area to area. Use the following information to answer questions 5 to 7. A study was conducted to investigate the association between the number of moths caught in a moth trap, less than 250, between 250 and 500, more than 500, and the trap type, sugar, scent, light. The results are summarized in the percentage segmented bar chart below. The question is also telling us that there were 300 sugar traps. We are asked to determine the number of sugar traps that caught less than 250 moths. First of all, we are interested in the sugar traps, so we look at the first column, and then less than 250, so we are going to look at the white segment. On the vertical axis, we have percentages. So this represents 30%. Now we have to calculate the number of sugar traps because this is what the question is asking. So we are going to calculate 30% of 300, which is going to be equal to 90. So the answer we are after is option B. From the 2017 VCAA examination report, 76% of students had the correct option, with 21% of students choosing the incorrect option A, and this was because they incorrectly assumed 30 traps instead of 30%. In question 6, we are told that the data displayed in the percentage segmented bar chart supports the contention or the opinion that there is an association between the number of moths caught in a moth trap and the trap type, and we are asked to choose the option that supports this opinion. First of all, to show that an association between variables exists, we need to make a comparison, and the comparison must be made for the same categories. Let's look at option A. most of the light traps contained less than 250 moths. This is actually a statement about the light traps. This is not a comparison. So for this reason, we can cross out option A. Option B, 15% of the scent traps contained 500 or more moths. Again, we just have a fact here, not a comparison. So again, we can cross out option B. Option C, the percentage of sugar traps containing more than 500 moths is greater than the percentage of scent traps containing less than 500 moths. Although we have a comparison here, the comparison is not made between the same categories. It is more than 500 moths for the sugar traps and less than 500 moths for the scent traps. So we can cross out option C as well. In option D, 20% of sugar traps contained more than 500 moths, while 50% of light traps contained less than 250 moths. Again, the comparison exists, but the comparison is between different categories. More than 500 for the sugar traps and less than 250 for the light traps. So we can cross out option D as well. In option E, 20% of sugar traps contain more than 500 moths, while 10% of light traps contain more than 500 moths. So we have both the comparison, and the comparison is between the same categories, more than 500 moths. So the answer we are after is option E. From the 2017 VCAA examination report, 71% of the students chose the correct option and 12% of the students chose the incorrect option C. In question 7, we are asked to determine the type of variables, number of moths, and trap type are. Number of moths is a variable where the data can be ranked. Less than 250, between 250 and 500, and more than 500. So the first variable is a categorical ordinal variable. Trap type, this type of data can be branded: sugar, scent, light. So the second variable is a categorical nominal variable. For this reason, the answer we are after is option E. Be careful with the word respectively, because this means that the variables have to be put in order. From the 2017 VCAA examination report, 46% of the students chose the correct option. However, 36% of the students chose the incorrect option C. And this happened because the students incorrectly assumed that the variable number of moths was numerical because it involved numbers. The use of numbers in a variable does not automatically make the variable numerical. Students should be careful to analyze whether the numbers are referring to categories for that variable, as was the case in this question. Use the following information to answer questions 8 to 10. The scatter plot below shows the wrist circumference and ankle circumference, both in centimeters, of 13 people. A least squares line has been fitted to the scatter plot with ankle circumference as the explanatory variable. The question is asking for the equation of the least squares line. Since ankle is the explanatory variable, we can cross out options A and C. Now we need the intercept with the vertical axis. Notice that the graph starts at the point with coordinates 21 and 16. We need to extend the axes so they start at 0 and 0 in order to determine the intercept with the vertical axis. If we extend the least squares line, this line intersects the vertical axis around 10. From the options, we can see that the second equation has 10.2 as the intercept with the vertical axis. So the answer we are after is option B. From the 2017 VCAA examination report, 43% of the students chose the correct option. However, 39% of the students chose the incorrect option D. Many students incorrectly assumed that the intercept value of the line was 17.4 read directly from the graph. However, this is only possible if the horizontal axis begins at value 0. Students are encouraged to look very carefully at graphs before choosing what might seem to be the obvious answer. In question 9, we are asked to calculate the residual when the least squares line on the scatter plot is used to predict the wrist circumference of the person with an ankle circumference of 24 centimeters. First of all, the residual is equal to the actual value minus the predicted value. Let's see what the actual value of the wrist circumference is. From the scatter plot, the ankle circumference of 24 centimeters, we go up until we meet the data point, and then we go across and we read the actual wrist circumference of 17.7 centimeters. The predicted wrist circumference is going to be on the least squares line. So from the 24, we go up until we meet the least squares line and then across to find the predicted wrist circumference of 18.4 centimeters. So the residual equals 17.7, take away 18.4, which gives us a residual of negative 0.7. So the answer we are after is option A. From the 2017 VCAA examination report, 52% of the students chose the correct option, with 13% of students choosing the incorrect option B and another 13% of the students choosing the incorrect option D. In question 10, the residuals for this least squares line have a mean of 0.02 centimeters and a standard deviation of 0.4 centimeters. The value of the residual for one of the data points is found to be negative 0.3 centimeters. The question is asking for the standardized value of this residual. The formula used to calculate the standardized value is equal to the score minus mean all divided by the standard deviation. The score is negative 0.3, the mean is 0.02, all divided by the standard deviation, which is 0.4. So the standardized value for this residual is negative 0.8. So the answer we are after is option A. From the 2017 VCAA examination report, 58% of the students chose the correct option, with 14% of the students choosing the incorrect option B and 13% of the students choosing the incorrect option C. In question 11, we are asked to state which one of the following statistics can never be negative. After reading the 5 options, we end up with the correct answer being option D, because the value of a seasonal index can never be negative. From the 2017 VCAA examination report, 59% of the students chose the correct option and 21% of the students chose the incorrect option C. In question 12, we are told that data collected over a period of 10 years indicated a strong positive association between the number of stray cats and the number of stray dogs reported each year in a large regional city, with a correlation coefficient R equals 0.87. A positive association was also found between the population of the city and both the number of stray cats, with a correlation coefficient of 0.61, and the number of stray dogs, with a correlation coefficient R equals 0.72. During the time that the data was collected, the population of the city grew from 34,564 to 51,055 people. The question is asking, what can we conclude from this information? First of all, an increase in population means an increase in the stray cats and the stray dogs. So because larger populations tend to have both a larger number of stray cats and stray dogs, the association between the number of stray cats and the number of stray dogs can be explained by a common response to a third variable, which is the increase in population size of the city. So the answer we are after is option D. From the 2017 VCAA examination report, 81% of the students chose the correct option. Use the following information to answer questions 13 to 15. The wind speed at a city location is measured throughout the day. The time series plot below shows the daily maximum wind speed in kilometers per hour over a 3-week period. Question 13 is asking to choose the option that best describes this time series. By inspection, we do notice that this time series is described by irregular fluctuations only. So the answer we are after is option B. From the 2017 VCAA examination report, 51% of the students chose the correct option, while 32% of the students chose the incorrect option C. Why did this happen? Well, many students incorrectly identified the time series graph as showing seasonality. The existence of peaks and troughs is not enough information to determine seasonality. They must exist with regular intervals of time between them. Students needed to observe that the peaks did not occur with this regularity and thus reject the existence of seasonality. In question 14, we are asked to determine the 7 median smooth maximum wind speed in kilometers per hour for day 4. First of all, the position of the median equals n plus 1 all divided by 2. In this case, n equals 7 because we have 7 median smooth data. So 7 plus 1 equals 8 divided by 2 equals 4. So we are looking for the fourth score. Looking at the time series, the fourth score is actually day 4. So we are going to determine the median on the horizontal axis. So we count 4 points from left to right. So the fourth point is the median on the horizontal axis. And now we count the points from bottom up Again, the fourth point is going to give us the median value on the vertical axis. So the 7 median smooth data for day 4 is going to be at the intersection of these two dotted lines, which is approximately 30 kilometers per hour. So the answer we are after is option D. From the 2017 VCAA examination report, 53% of the students chose the correct option, with 26% of the students choosing the incorrect option E. In question 15, we are given a table of values that shows the daily maximum wind speed in kilometers per hour for the days in week 2. A 4-point moving mean with centering is used to smooth the time series data above. The question is asking for the smooth maximum wind speed in kilometers per hour for day 11. We are going to start by constructing 2 more lines above the table, one for the 4-point moving mean and one centered. We need the values in the 2 boxes above 11. So we are going to calculate the mean for days 9, 10, 11, and 12, which is 26.5. Now we are going to calculate the mean for days 10, 11, 12, and 13. And this is 30.25. Now we are going to calculate the mean of these 2 values to center the data. So the centered mean is going to be equal to 26.5 plus 30.25 all divided by 2, which gives us 28.375. And this is close to 28. So the answer we are after is option D. From the 2017 VCAA examination report, 64% of the students chose the correct option. In question 16, we are told that the seasonal index for the sales of cold drinks in a shop in January is 1.6. We are asked to calculate the actual sales to correct the January sales of cold drinks for seasonality. So let's start with the formula. Deseasonalized sales for January equals actual sales divided by the seasonal index for January. This can also be written as 1 over the seasonal index for January times the actual sales. Then we substitute 1.6 for the seasonal index for January, and we calculate 1 divided by 1.6, which is 0.625. So the deseasonalized sales for January are equal to 62.5% of the actual sales. So the actual sales should be reduced by 100 minus 62.5, which is 37.5%. So the answer we are after is option A. From the 2017 VCAA examination report, 32% of the students chose the correct option, with high percentage of 22% and 27% of students choosing the incorrect options C and D respectively.